Hi again. Okay, in the last section we looked at the way that computers worked out things like subnets and broadcast addresses and valid host ranges applicable just by knowing their own IP address and their own subnet mask. What we're going to do in this section is show you a trick because in the CCNA exam you're going to have to do essentially the same sort of thing, but you're going to have to do it much faster than we were looking at before. We haven't got time to change everything into binary. So let's have a look straight away at a typical sort of CCNA type question, an IP addressing question. And what it says here is, given the IP address 172.16.12.54 with a mask of 255.255.255.240, which of the following are valid host addresses on the same subnet? And then we've got a whole list of addresses, some of which are hosts, some of which are network addresses, some of which are broadcast addresses. We've got to work out which ones are which. So let's see how we go about that. First of all, we've got the address 172.16.12.254 with a mask of 255.255.255.240. The magic part of this address is the last octet. Obviously the mask is going to be 255.255.255. That means all ones, all ones, all ones. So it's going to be 172.16.12. something. It's the dot something we need to find out. So concentrate on the 240 at the end, the last octet. What we're going to do is use a magic number. We're going to subtract 240 from a magic number 256. And if we do that, the result is 16. Now what that 16 is are the steps that the subnets go up in. So every subnet is a step of 16. So what we can do now is list all of the different subnets that are that can be created using that mask. So the first one is subnet 0, then the next is 16, the next is 32, next is 48, and so on. So we've created a list of all the different subnets, and all we have to do now is look at the addresses in the list we've got there on the left and work out what the devices are. Now remember, if they're all the subnet addresses, so 0, 16, 32, 48 and so on are subnet addresses, then the broadcast address for each one of those subnets is one address before the next subnet. So for example, the broadcast address for subnet 0 is .15, one before 16. The broadcast address for subnet 16 is .31, one before subnet 32. The broadcast address for subnet 80 is .95, one before the next subnet, .96. So now we know the subnet addresses, we know all of the broadcast addresses, or we can easily work out the broadcast addresses, and now we can find out which ones of these are hosts. So let's just have a look down the list. First one we've got there, .64. .64, as we can see from the list on the right, is a network. If we look at the next one, .57. .57 lays between .48 and .64, so it's a valid host on subnet 48. .49 is again a valid host on subnet 48. It's the next available IP address after the network address. .48 is the network address itself. .63 is a broadcast address. It's one address before .64, so it's the broadcast address of subnet 48. And .45 is also a host address, but this is a host address on the previous subnet. This is a host address on subnet 32. So now we know which one's a network, which one's a broadcast, and which one's a host. I think the question asks us which ones are on the same subnet as .54. Well, .54 is on subnet 48, so the only two hosts there that are on the same subnet are .57 and .49. There's the answer. We're done.